Hi there, everybody. So today we're going to be talking about attacks from the 4G and 5G core. And if you were sitting in your control system and you started seeing your furnace temperature skyrocketing and falling without ever setting off any of the alarms, you would think that something might be going wrong. Either you have some sensor problems, or that you have, PLC maybe isn't communicating properly, or that somebody is interfering with your communications. And so what we wanted to look at was if somebody were to go ahead and put in a campus network, how could you, or how could somebody interfere with that campus network and cause changes, on the control system. So we started looking at the 4G, LTE, and 5G networks that are available. There are still some 2G and 3G available around the world, but that's being gotten rid of. And 3G, for the most part, has pretty much gone. There are still some 2G in Europe and certain areas that still exist for backwards compatibility reasons. So looking at LTE and 5G, we wanted to look and see what kind of private network are available, or campus network, and what we can do on those networks. So within the 4G system, or 4G networks, you have what they call private APNs. And private APNs is you put in a specific name of your APN, and instead of being on the AT&T public network, you get pushed off onto the AT&T private network for your specific company. And then all that traffic gets routed back into your environment. You can now do that with campus networks for 5G. Those are also called non-public networks, NPNs. So looking at the different 5G non-public networks, you have a fully contained, completely isolated 5G network where the company is in charge of operating in the 5G network entirely by itself. You do have to work a bit with the FCC because the frequencies you're going to be using may be a little bit, may conflict potentially with other frequencies. So you need to make sure that there's a deconfliction, or that it's entirely kept within a building and there's no leakage outside of that building. Another option is deployment with shared RAN, so that's the radio access network. So you can actually communicate and send some information back and forth to the public network. However, all of your actual data stays on premises, that your data for your processes do not leak out. It just has some communication up to the public network. You have essentially the same type of situation, except you don't have a control plane that you manage. You allow the cellular network, the telco, to manage the control plane. And so just one less thing that you have to manage, but all of your data is still on premises. And then the final one is kind of what we've seen within 3G and 4G, where you have a kind of a private APN that you use, and they send data back into your network. So the components for 4G, you have the actual components aren't really necessary to know, but you do have like the home service. I can't remember the name of it. You have some gateways in there, and then you have the base stations which connect back into the different components. Now for the 5G hybrid networks, what you have is essentially the exact same thing. They just add a 5G base station. So you're not getting anything really new except the speed and the kind of some of the 5G attributes. Now what happens next is they have the standalone 5G, and that is a completely different set of servers. So you're actually using commercial off-the-shelf servers instead of using servers for very specialized hardware. which you were in 4G and 3G. And then you're also using containers. So pretty much every one of those servers that you had before, they are now containerized and running on those commercial off-the-shelf servers. And then you don't have any 4G base stations. It can only handle 5G at this point. There is no backwards compatibility with the 5G standalone components. Right. So this does have some potential new entry points. And those entry points are the commercial off-the-shelf servers. Now you have to be aware of what HP lights out vulnerabilities there are on the servers, or your Dell Drakes, the remote access cards. So you actually have to pay attention to what's going on out there and not just be aware of what's going on the specialized hardware that you had to before. You also have to be aware of what vulnerabilities there are with Kubernetes and Docker and some of the packages that are being run on your 5G core network. The routing is now done through standard Cisco routers. So this is looking more and more like your standard IT kind of system now. The only new component really is you have your GNB. So you have the cellular node, essentially, and you have to make sure that those are up to date, in latest firmware, no vulnerabilities. There is another component, and you do have to be aware of potentially malicious phones, user devices. So, because of these different entry points, because of this kind of move to doing a campus network, we wanted to set up our own lab and do some testing on our own. So our lab here was using a small cell device. So this is actually a 4G lab that we had set up. This lab costs a little under $10,000 to set up. If you want to do the 5G lab, it's probably around $40,000 to set up the whole lab. So the small cell device was connected into our core network, and then our field network was connected into our industrial router, and the core network was connected into the control network through a firewall and a router. The small cell device, the eNode B, and the industrial router were connected through a Faraday cage because we were hosting our own cellular service, but we weren't allowed to host one, so we had to ground that out and make sure that nobody complained. So we move on now to the attack scenarios. And in order to understand the attack scenarios, real quick, here's a diagram of the network. So you saw the actual physical servers. On the physical servers, this is what we had. We had an MQTT server way out on the internet, and then we set up kind of a Purdue model type, and we had some firewalls and DMZs. But what the real interesting part starts kind of in the middle of that screen where you get to the core network and the attacker foothold. Now, we did not show anybody how to break into a core network. That's not what we wanted to do. We just wanted to show you what you could do when you were there. So there are core networks out there that have been breached for major telcos. You can read up on those if that's what you're really interested in. But that's not what we were doing. So we just put in a user on that, on the core network. And then we also hooked up the control network, which we threw a historian on, a TIA portal on for the couple of S7s that we had, threw on VT SCADA for an HMI, and then threw another MQTT server internally. And then in our field network, we had the Sierra Wireless RV50 X, and we threw another HMI in there using some open PLCs and a Moxa protocol gateway that we had left over from another project, and then some S7s. And one thing that we found was the first thing that we found when we were setting all this stuff up, we went through and looked at the base station that we had. And we actually found vulnerabilities in the base station. So this one, you could dump the pre-shared key for IPsec if you wanted to, without or as an unauthenticated user. And there was also a way as an unauthenticated user to turn IPsec on and off if you so chose. So there were some issues with the base station itself, something to be aware of if you're going out and either testing with the base station. Sometimes they're not considered critical, or because it's a lab system, they won't fix any of the vulnerabilities that are on the base stations if it's specifically set up for a lab. So something to be aware of when you're talking to a provider of the base stations. So there are a few different ways that you can, that we could do some of the testing and do some of the vulnerability testing, or do some of the man-in-the-middle type of attacks that we did, or certain other attacks that we did. But we wanted to do man-in-the-middle attacks in transit as opposed to doing some kind of ARP attack or something like that. So what we did is using NetFilterQ, some SCAPI, and some Linux, some IP table filtering. We were able to do modification of the packets on the fly, which was kind of slick. I liked it. And one of the first ones that we did was DNS hijacking. And you can either do a local DNS hijacking if you take over like the etc root or etc host file. If you break into a router and you can change some of the routes or some of the name resolution, you can do it that way. We went with the man-in-the-middle type of attack. Additionally, you could use like a rogue DNS server, set that up, and have it answer different, or have it create answers. So this is kind of a walkthrough. Step one, you're trying to get to S4X events. 2, DNS server returns 1.1.1.1. Our malicious user changes it to 9.9.9.9, and we get sent off to a different server. And so we have a quick little run through, going through the just kind of redirecting traffic to a different site, and we get to see that in fact is not S4X events. So, and you can see kind of how the answer was initially returned, and then the modification that was done with that. We did another similar type of attack on MQTT. So MQTT is if you're not aware, it's a push subscribe or publish subscribe method. So the probes would sit there and they would publish out to channel 1 on the MQTT broker, and then the computers over there on the right-hand side, they would subscribe to that channel 1, and they would then get that probe data. So what we did is, on the left-hand side here, we have the actual client that is reading the temperature from probes. On the right-hand side, we have the malicious user that is going to be dropping the temperature by 20 degrees. And on the bottom right, you have the server that's receiving the temperature. So as soon as we launch the attack, now you see that the temperature is returning quite a bit lower. And this will go for a few more times, and then it goes back to the standard temperature. So relatively easy attacks, and it's just changing the data as it's passing through on the network. We also did some remote key logging. This was a tool that we picked up when we were doing some of our honeypot work, and you have VNC logger, and if you have an unencrypted version of VNC, then pretty much anything that you type in there, you can monitor and do key captures of within VNC. So, and it just outputs it to the screen there, and you can also just have it capture it off to a file if you want to. There's actually a couple other programs out there. Chaos Reader will do a similar type of clear text capture. So. Now, the next part here, we go in and do some messing with ICS protocols and doing some man-in-the-middle of ICS protocols. So if you were here 10, 12 years ago, INL was really big into man-in-the-middling of ICS protocols, so you get to see a little bit of that again. So here we have our the steel mill. I was watching a lot of Forged in Fire, so we set up a steel mill just because. We have the alarms over there on the right-hand side, and the max temperature, and below that, and on the left-hand side, we have the temperature of the actual furnace, and then down below, you have the pressure in the furnace, as well as kind of the valves for the air going in. So now, what we're going to do is we start modifying a lot of the data that's going to the control HMI, but we're not even touching anything out in the field. So this here, you can just see it going crazy. So your operators are probably saying, "What the heck is going on here?" In the next one, we actually start modifying the field HMI and the actual device itself. So we're actually sending commands to the device itself, and so it starts increasing. And you can see that in the control HMI, the actual temperature stays under 2,000 or 12,000 until now. The max temp, for some reason, was fluctuating. I don't recall why it was doing that, but so you can change one side or the other. You could have both the field HMI as well as the control HMI return perfectly good-looking information while having the actual PLC doing something completely different. So multiple ways to affect the control of that. Another thing that we saw within the Sierra Wireless RV50, they had you could do SMS commands on that device. So this wasn't really particular to 4G and 5G, but this was the device that we had, and so we took a look at it. And if you sent a password along with like the status command, then you would get back some interesting information. And there was really no maximum limit, so you could just keep trying the password over and over again. And it was nice enough to tell you when you got it wrong. The other text that we did, PLC reset, just erasing the logic on the PLC. Some pass the hash, so your standard Microsoft passing of the hash. Emergency alert abuse. So this is something, none of the devices that we had any vulnerabilities with the emergency alert, but it would be something worth testing if you are going to start setting up a bunch of cellular devices in your network. Check to make sure that the emergency alert does not crash whatever device it's being connected to. So, and then there's SIM swapping or SIM jacking, so taking out the SIM from a device that's supposed to be connected, and then taking that and then connecting with a malicious device. So something else to be aware of. So recommendations. Do your own testing, or you can always hire somebody to do testing. But so do some testing, and encryption whenever possible. Don't rely on the telcro to be encrypting anything. Don't rely on the integrator that is supposed to set everything up correctly to be encrypting everything. Try to either use a VPN if it's going to like a substation or something like that, or to some remote site, or IPsec, or if you can, have application layer security in there. You have to do patching of all of your 5G components now if you're going to be running your own 5G system. So make sure that that you add that into your patch queues. And then network monitoring. Make sure I mean, this is an extension of your network. Make sure you're doing what you should be doing with the rest of your network on the 5G network as well. Find anomaly or campus network aware anomaly detection software. There's a couple of them out there, so find them and use those. And then the other thing is, if you're looking at either doing the 4G private APNs or the 5G APN slicing, be aware of how the telco does that slicing and what they're actually providing for you. How is it being routed? How is that information being protected on their side? So, and I'd like to thank Reiner, Phil, and Lin from the Institute of Information Technology in Taiwan. So Phil did most of the 5G side. Wen did a lot of work on the base station. He did a very good job, and Reiner kind of got us all together. So just want to thank them, and I think that's pretty much it. So if we have time for questions, if there's microphones on the right and left.
So from the point of view of the asset owner, when they're looking at trying to understand the attacks that may be coming in via their campus network, could you describe like the roles and responsibilities of who's setting up the campus network, who typically runs it and is responsible for the operations within an organization?
Certainly. So essentially, whoever is purchasing it is responsible. Now you can have an integrator come in and set up that network if you want, and you can have somebody else kind of maintain it. But you, as the company that has purchased the campus network, you are basically responsible for everything in that, unless you contract that out to somebody else. So.
Thanks, Charles.
Yep.
Great presentation, by the way.
Thank you.
Just curious on when you're talking about attacking the core network and anything in there, I was wondering if there's any other pivoting investigations that was done as part of that. So I'm thinking about from the other side, when you have your campus network set up, if you're looking at there, what other ways could get involved with that core network?
So if you have the campus network, in this instance is the core network, right? So if you're doing it all as a campus network, if you're doing it as from a telco point of view, then trying to get into the telco which is it's possible, but difficult. So
maybe I can rephrase.
Yeah, if you can clarify.
I'm thinking more from the telco perspective. So I know we're looking at the campus network, but
Mm-hmm.
if the telco is compromised, is there a segregation there that's managed by them that is not under the control of the campus? Is kind of what I'm just wondering. When you brought up the chart between 4G and migrating that into 5G, and when you start adding layers on top of layers, I just suspect something could get missed, because we see a lot of the 5G networks brought on top to maintain backwards compatibility. So
Mm-hmm.
I'm just curious how the network intertie, especially when you're sharing frequencies and.
So if you have a setup where it's the telco is providing you like a slice of an APN or a private APN, then that would be you'd have to. I don't know. I'm just not sure right now. I think I need to talk.
We'll chat tonight then.
Talk a little bit later. Yeah. Sorry. Yes.
Thank you. So I'm working with a client right now that's actually going through this process of evaluating private LTE solutions.
Mm-hmm.
And in the responses that we're seeing from the major vendors of network cores, basically all of them say, you can't put anything in our network core to monitor it. And I'm wondering what strategies that you might be aware of for protection from an owned network core, other than doing what we regularly do and building a bunch of walls around it.
So So this is more like doing the APN splicing or the private the private APN? Is that kind of what they're doing? Or are you doing an on-site
No, on-site network core.
on-site network
you
core,
know,
but they won't let you do any kind of monitoring? I mean, you get to monitor certain parts because it has to come from the core into your own network.
Absolutely.
So there's at least that point that you can start monitoring.
We obviously have the ability to monitor everything that's flowing from the RAN sites to the core.
Right.
But you start looking at the core and you start talking about, malware, scanning, monitoring, those sort of things, and the major vendors' positions are basically, no, this is our special box. You can't put any agents on it, you can't scan it, you can't do X, Y, or Z. This is, you buy this box from us and it's a locked thing. And I'm curious what sort of strategies you've seen for monitoring the core itself.
I mean, they may say that you have to not
We
look
don't
at
have
it.
to play
but-
by their rules, but
I mean, if you're paying for it, then. I can get you in touch with Phil. He would probably know better what actual technologies.
Okay. I'd appreciate that.
So I'd get in touch with Phil. Anything else? I think we're good. All right. Thank you very much.